I guess.
Everyone who
Okay.
matters.
Okay. All right.
Everyone who's anyone.
Just let me know when we're good.
Did I just say Thomas
Okay.
doesn't matter? Sorry, Thomas.
Aw, I'll wait for Thomas.
Hey, Ricky showed up. Frederick, how are you?
Please hurry, Thomas. I'm about to start.
Thomas.
Okay. I'm going to rip off many things from Matt Biondi because I don't know how to present. So, first and foremost, my name is Lucas, as many of you know. I'm a third year majoring in astrophysics, and my introduction to my short course is going to be on the end of the universe, otherwise known as eschatology, which has its roots in the Greek word for last, I'm pretty sure. Okay. So essentially, there have been three main lines of thought over the course of human history about the end of the universe at large, not the end of the Earth. There are so many possibilities for that, but for the end of the universe, there are really three main lines of thought. The first, and one I find pretty interesting, is called the Big Crunch theory, and what that entails is that the universe will eventually one day collapse back in on itself. And how this happens is by the gravitational pull of everything else in the universe. So a good analogy is to think of a ball thrown into the air. So if you throw it with little enough energy, it will come back down to the ground. And that's what this graph is. This is you throwing the universe outward and it having not enough energy to escape its own gravitational pull and falling back down into itself. And something really interesting that I found about the Big Crunch theory is that it might imply that the universe has done this multiple times over, and so it just kept bouncing and bouncing. So we might be in like the umpteenth loop of the universe. But due to what Matt Biondi has recently stated, it's found that the universe is actually expanding, and there's even more proof for inflation theory as of late. So we can be fairly certain that this is not happening. So the analogy now is you've thrown the ball upward with enough energy to escape any gravitational pull. So that's what this graph is. And we call that the big freeze. And why it's called the big freeze is because the universe will continue expanding ad infinitum, like forever. So what happens is everything gets so far apart that nothing really interacts with each other, and so it gets extremely cold, like basically absolute zero without actually being absolute zero. But that has a lot of interesting implications, like how the universe will evolve. For example, a lot of people who study this, cosmologists, have divided the universe into eras, such as right now we're in like the biological era, and eventually there's going to be a black hole era, and then eventually even those black holes will die out due to Hawking radiation, which I can go over in my short course. But eventually even those black holes will die out, and so no form of life will be able to survive. But there is hope, of course. You can always, as some scientists speculate, create your own universe or travel to another one. But that's the big freeze theory. Another really interesting theory is more on a quantum scale than anything, called the Big Rip theory. So what this one is, it's kind of difficult to put into actual words, but analogies are always fun. So a lot of people like to think of it as the universe is a dealer constantly reshuffling the deck, and there's enough of disorder in it for it to remain relatively the same. So eventually, there's going to be a spike in order. Imagine laying out a perfectly, like shuffling the deck, and you flip over the cards, and it's ace, 2, 3, 4, all in the same suit, all the way through all the suits. This would be the amount of like random order needed to restructure the entire universe. So what happens is the laws of physics are basically rewritten for this one tiny point in space, and it expands over the entire universe, which could potentially end the universe at any moment, blah, 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 don't worry about it. So the Big Rip is essentially a kind of spin-off of quantum field theory, which is where we get a lot of the components for the Big Bang theory. But again, this is something I can go over in my short course. I think that's about all I wanted to cover. Any questions? Like, I just really wanted to give a good intro, get people's interest. Yes, Beane.
What is the probability that the universe will end in the next 8 seconds?
6.
Hmm.
4.
I want to say effectively 0.
Okay. But not just effectively.
Did you have one else?
Yeah, so talk a little bit more about the big freeze. That sort of presumes that the universe is expanding, but the amount of energy is constant.
Okay. Yes. Okay. I was hoping someone would say that because I did not go into that nearly enough. So the big factor, or the big factors in whether or not the big freeze theory or the big crunch theory is the correct one, is the amount of matter in the universe and the amount of expansive energy. So scientists originally thought that the amount of expansive energy was just the initial velocity that the universe started out with. But we're discovering more and more that there's this elusive new expansive energy called dark energy, just because we don't know what it is, can't really see it. So what's happening is instead of this decelerating at all, it's actually accelerating. This would be the universe if it weren't accelerating at all. It would just continue expanding at a steady rate, but our universe is accelerating in its expansion. In fact, we're about, like, right here, we're just barely able to tell that it's not a straight shot from 0. Right here, you would be able to see that you might think that you're in a universe that doesn't have accelerated expansion, but we're at a point where we can go, oh wait, this traces back to not quite 0. So
That was actually in the graph on my PowerPoint. There was it was with respect to time, it was basically conical, but you could see there was a straight line and then it started flaring, and there was a point to that where it was like dark matter expansion.
yes.
So,
And oh, sorry.
yeah, so to follow up then, presumably then if the energy keeps coming out, the loss of energy to the universe kind of could possibly be balanced out if the rate of increase of this energy were sufficient.
That is correct, but we have no evidence to believe, like, we have no reason to believe that this energy is going to cease existing or cease functioning, however you want to put it. We just know that right now it's accelerating. We don't know the mechanisms behind it, but everything points toward continued acceleration.
Wait, continuing acceleration or accelerating acceleration?
Ooh, good question. I'll have to look into that. Continued acceleration, I know that. I would assume accelerated acceleration, but
Continuing acceleration would be constant. Accelerating acceleration.
I would assume accelerating acceleration, but I can't be 100% sure.
That would make sense because as it expands, it would get more energy.
Exactly, because the energy of dark energy is the energy of space itself. So
Right.
as it's expanding, it's getting more space, so it should have more energy. But anyway. Any more questions? Okay, thank you. Yay! They're the best.